Okay, so we're going to start talking about modelling geometric growth and decay. So this is far closer to what happens in real life, especially when it concerns interest. We're far more likely to see that geometric growth. So we see this in real life situations such as compound interest, which is usually the interest we get, or reducing balance depreciation. So geometric growth, you can see, exists non-linear growth, where it's increasing by different amounts every day. So the formula here is Vn plus 1 equals R times Vn. Or in other words, the next value is what the last value was times by some rate. Okay, so here, for the example I've drawn here, I've got V0 equals to 2, Vn plus 1 equals 3 Vn. In other words, 3 times Vn gives you Vn plus 1. And I've done a little table of values here as well. So when n equals 0, our Vn is 2. When n equals 1, our value is 6, because it's 2 times 6. You can see here that while n is increasing by 1, that value is, being times by 3 each time. So it's not going up by the same amount each time, it's increasing. The amount it's going up by is increasing. So this is what compound interest is, and this is why banks and credit card companies use it to calculate the interest that you owe them. Okay, so we've got a similar model for our decay as well. So it's going down by different amounts each day, or each n. So Vn plus 1 equals R Vn. So this is when R is less than 1. So up here, for increasing, I had R being greater than 1. So whenever you times something by a number greater than 1, it's going to increase, doesn't it? That's what happens. When you times something by 1, it stays the same. When you times something by a number bigger than 1, it gets bigger, it increases. But when you times it by something less than 1, and I'm talking here a number between 0 and 1, it decreases. So here I've got V0 equals to 10, Vn plus 1 equals 0.5 times by Vn. And here's my table of values. So start off at 10. Then my n increases to 1, so we've got V1 is equal to 5. That's 10 times by 0.5. 2. When n is equal to 2, I've got the 5 times it by 0.5, so that's 2.5. 2.5 times by 0.5 is 1.5, and so on and so forth. So you can see how, at the start it was going down by quite a bit each time, but it's reducing how much it's going down by each time. Where here it was increasing how much it was going up by. This is compound interest and our reducing balance depreciation. That's where we get the name from, that reducing balance. Okay, so you can see here why banks and credit card companies, they like compound interest for calculating the interest you owe them, because the longer you don't pay, the more you owe them. All right. So have a think about that when you are taking out any personal loans. So for a car or when you get credit card, you want to be paying it off on time. Otherwise, they'll start charging you compound interest. So that's where we start talking about here, these compound interest investments and loans. Remember, investments are things like where you put things into a bank account. So compound interest is more common in real life. So in real life, we really only deal with compound interest. So those payday loans, so like can't remember the name of it now, but those loans you can get very quickly for small amounts up to $1,000, they start charging you interest the day you borrow. So by the time you pay them back, it might be a lot of money. So you've got to be very, very careful with any loans you take out. So any interest earned, so that's what you earn interest if you've invested your money, or incurred, that's when you owe money with a loan or credit card, after a time period is added to the principal. So with simple interest, we only owed the interest that was charged from the principal at the start. But now we earn that interest, or the interest is incurred, and then it's added to the principal. So that the next time interest is calculated on that new amount. So here's a small example here. An investment in the bank earns 4% per annum. We invest $500. How much will be in the bank after N years? So using our recursion, start off with $500, and that's our recursion rule, recursion relation. Vn plus 1 equals Vn plus 0.04 times by V0, that should be, miswritten that, haven't I? Just noticed that should be V0. So anyway, easier to see on what's happening on our CAS calculator when we do it. Okay, so the first year we invest $500. Then we earn 4%. Now, take a moment. Why have I written 4% as 1.04? Now, if you've said because it's increasing by 4%, you'd be correct. So I've written it as 1.04 because if you times something by 1, it stays the same. If I times something by more than 1, it increases. So you can imagine that 1 is the representation of 100%. So if I times something by 100%, it stays the same. Here, you can imagine I'm timesing it by 104%. So I'm wanting it to increase by 4%. So that's why I times it by 1.04. Anyway, so I've times 500 by 1.04 and I get 520. Then, the next year, I'm timesing it by 1.04, but I'm timesing the 520. So I get $540.80. You can see that first year it's gone up by $20. The second year it's gone up by $20.80. Year 3, that calculation, we use $540.80 times by 1.04, and we get $562.43 to the nearest cent. You can see it's gone up there by $22.43. So that compound interest is a very powerful thing. So we've got here our general sort of rule. For yearly, if we're talking yearly, our principal, V0, Vn plus 1, R, Vn, where R equals 1 plus R over 100. So we're given our little r is the percentage interest per compounding period. Now that's an important phrase there. Compounding period. Compound period. This is how often is interest calculated. Now, that is very important. So to take some examples for real life, on my mortgage, they calculate the interest on my loan from the bank monthly. So every month they calculate how much interest. So that's my compounding period, is monthly. Now those payday loans I was talking about before, their compounding period is daily. Daily. So you can imagine how quickly how much you owe can increase with one of those loans if their compounding period is daily. Now, some things compound yearly, not many though. Real life, as I said, our mortgages, car loans, personal loans, they might get compounded quarterly or monthly. So we get given our rate, our R. Usually they say it as the per annum rate. So when it's quarterly, we have to divide it by 4 because we're doing that calculation 4 times a year. So we've got to have that interest rate 4 times throughout the year. So when compounding monthly, we get the per annum rate and divide it by 12 to spread it out. Okay. So you've got to make sure that when you are reading the information in a question or on a application for a loan or credit card, you are reading how often that interest is calculated. That compounding period, it's very important. So, our reducing balance depreciation. So in reducing balance depreciation, the value of the asset would be reduced by a percentage of the previous year's value. So with flat rate depreciation, it was being reduced by the same amount each period, whereas with reducing balance, we look at the last year's value and we do a percentage of that. So it's going to be going down by different amounts every year. So we've got our occurrence model here. We've got our initial amount and our rate. There's 1 minus. Now again, why is it 1 minus? Because we want to reduce the amount. If you times a number by less than 1, it reduces, it decreases. Let's go through a couple of these examples. A transport company has bought a new bus for $60,000. This depreciates at a reducing balance rate of 30% per annum. So find the recurrence relation. Let's write it out. So we've got that it depreciates at 30% per annum. So that means that this year's value is 70% of last year's value. How did I get that? 100% take away 30% is 70%. Or 1 take away 0.3 is 0.7. And that's where I get my recurrence relation from. Okay, use this relation to find the value of the bus after 1, 2, and 3 years. So after 1 year, it's going to be worth 42,000. 70% of 60,000 is 42,000. Then, for the next year, I apply that 70% to the 42,000. So my value is 29,400. Then I apply that to the third year to get a value of 20,580. So you can see that as the years go by, the amount it decreases or decays is getting smaller. It's getting reduced. So $1,000 is invested at an interest rate of 7% per annum with interest compounding monthly. What is the recurrence relation that models this investment? Okay, so VN is the value of the investment after N months. Okay, so it's 7% per annum. So that means that per month is 0.58%. I'll just write that out, 0.58%. Okay, so writing that out, that rate is 1.0058 because, and that, do you remember why that one's there? Because it's increasing. Okay, it's increasing. If I only was timesing it by 0.0058, I would get a lot less than what we have in there. This is telling us how much that new value is going to be. So V0 equals 1,000. Vn plus 1 equals 1.0058 times by Vn. So what is the value of the investment after 4 months? So $1,000 starting with. So after 1 month, $1,005.80. 2 months, you can see we've taken the new balance, times it by our rate to get $1,011.63, and increasing and increasing. Okay, so the value of the investment after 4 months is $1,023.40. Now, when I did this, I double checked that rounded to close to 40. Okay, please don't ever write money with just 1 decimal place. It's always to 2 decimal places, and we're always checking our rounding. We're always checking that our calculator's giving us our most precise value. Okay. Now, just in case you've forgotten how to check, I've done it again. So what I've done here is I've just arrowed up to my last answer, and then I hit enter. Okay, and that gives me the full answer with little to no rounding in it. And you can see it's closest to to $1,023.40. Okay, you always need to double check, because your CAS calculator, when it's working things out, will cut things off. You can see by this example here that it has cut off a fair amount of information. You always need to double check, what the full answer is. Okay, and it's just that simple, just as simple as I say, arrow up, hit enter, there it is. Okay, so we'll do the past exam questions in the next video.